Hello friends, Mr. Burrell here. We're at the end of Unit 5. We've been talking about radicals, simplifying cube roots, and square roots. We just finished the lesson talking about complex numbers, what they are, and how we add and subtract them together. So today we're going to wrap up this unit by talking about multiplying complex numbers. How do we multiply complex numbers? How is it similar to what we've done before, and how is it different? So by the end of this lesson, these are the things that I hope you're able to understand. I want you to understand that I squared, when I take an imaginary number squared, is equal to -1. And that I is equal to the square root of -1. We reviewed this a little bit already. We're going to kind of wrap it all up nicely with a bow. I hope you're able to multiply complex numbers and understand that multiplying complex numbers is similar to how I multiply polynomials. So let's get right into it. So as a reminder, again, we started off this whole unit talking about square roots. We talked about how 2 is equal to the square root of 4. 2 is equal to the square root of 4 because 2 times 2 is equal to 4. That's the definition of a square root, is that if I have the square root of something like 2 is equal to the square root of 4, that's the case because 2 squared, or 2 times 2, 2 times is equal to 4. That's the definition of a square root. So in this last lesson, we talked about how I is equal to the square root of -1. When I square root a negative number, there's not a real number that's going to fit that description. I can't take two real numbers and multiply them by themselves and get a negative number. So the square root of a negative number is equal to an imaginary number, or I. And in turn, I times I, or I squared, is equal to -1. That's the big kicker that we're going to use a lot in this lesson, is that I squared is equal to -1. They're interchangeable. I could write I squared or -1. They're equal to the same thing. Just like 2 and the square root of 4, or 2 squared and 4 are equal to the same thing. So let me show you an example. So say I have I multiplied by 3 plus I. In the last unit, or in the last lesson, sorry, we talked about how complex numbers behave pretty similarly to how polynomials did, and I could add and subtract them in the same way. Same thing goes here. If I have, say, x times 3 plus x, when I multiply those together, I'm going to go ahead and distribute this x into both of the terms in the parentheses, and I'm going to get 3x plus x squared. Done, done, done. That was it. Right? That wasn't too bad. We felt pretty good about that. When I have an imaginary number, it behaves a similar way. I multiply this I into the parentheses here, and I get I times 3, which is 3i, I times I, which is I squared. And when we were talking about polynomials, I'd be done here. That would be it, 3i plus I squared. However, remember on this previous slide I told you that I squared is really the same as -1. So 3i plus I squared is really the same as 3i plus a -1, or 3i minus 1. So that would be my final answer. 3i plus I squared would be equal to 3i minus 1, or oftentimes complex numbers are written with the real number first and the imaginary number second, so it would be -1 plus 3i. That's the only difference with what we're doing when we're multiplying complex numbers, is because when I multiply two i's together, I get I squared. I squared is equal to -1. Notice that I times I is -1, so like I times I times I would be -1 times I, which would be -I, and you could keep going on with that. I times I times I times I. These two would make a -1. These two would make a -1. -1 times -1 is a +1, etc., etc. So when I multiply two i's together, or I squared, I get -1. Let's look at some examples here. So here I have 8i times 5i. So if I multiply those together, 8 times 5 is 40. I times I is I squared. Okay. Back when we talked about multiplying polynomials, this would be it. But I squared, write this big somewhere so you don't forget it. I squared is equal to -1. So 40 times I squared is really 40 times -1. Well, what's 40 times -1? negative 40. So my answer would be negative 40. Notice the i's just go away. They're not even there anymore. Okay. Let's try this one. 3 plus I times 4 plus 2I. So remember, when I have two terms multiplied by two terms, I need to make sure everything in the first parentheses is multiplied by everything in the second parentheses. So I take 3 times 4. 3 times 2I. I times 4. I times 2I. See that? 3 times 4 is 12. 3 times 2I is a positive 6I. I times 4 is a positive 4I. And I times 2I is a positive 2I squared. Okay. So, any like terms I can combine? Yes. 6i plus 4i, that's going to give me 12 plus 10i plus 2i squared. And if this were the polynomial unit, I'd be done. But I squared is equal to negative 1. So really this is 12 plus 10i plus 2 times negative 1. And 2 times negative 1 is just negative 2. Yeah, 2 times negative 1 is just negative 2. Well, now are there any more like terms I can combine together? Indeed, 12 minus 2 is 10, and my final answer is 10 plus 10i. 10 plus 10i. You'll notice with all these problems, with all these complex numbers, after you multiply and combine like terms and add things together, the end result will be no more than two terms, a real number and an imaginary. Some will only have one term, some can have two terms. I won't have any more than that. Okay, let's do this one, negative 4 plus 3i times 7 minus 6i. I'm going to do the box method for this one, for those who use the box method for multiplying polynomials. I'm going to write negative 4 plus 3i along the top and 7 minus 6i along the side. So let's see, negative 4 times 7 is negative 28. 3i times 7 is 21i. Negative 4 times negative 6i is a positive 24i. And 3i times negative 6i is negative 18i. Squared. Whoops. Negative 18i squared. Okay. So I'm going to have negative 28. If I combine these i's together, I get 24 plus 21 is positive 45i. Remember, when I'm adding the i's together, the exponent doesn't change. It just stays 45i. And the negative 18i squared is really negative 18 times negative 1. Which is negative 18 times negative 1 is the same as positive 18. So I have negative 28 plus 45i plus 18. Well, now I can combine these numbers together. Not the I, just the 18. Negative 28 plus 18 is going to give me a negative 10. Negative 10 plus 45i, that is my final answer. Negative 10 plus 45i. Okay, let's do a couple more examples. Let's do this one. We have 4i times negative 3 plus 6i, so I just have one term multiplied by two terms. I'm going to go ahead and distribute. Everything in the first parentheses needs to be multiplied by everything in the second parentheses. 4i times negative 3, that's negative 12i. 4i times 6i is a positive 24i squared. And again, back in polynomials, that would be it. I'd be done. But I squared is equal to negative 1, right? So this is really negative 12i plus 24 times negative 1. Well, 24 times negative 1 is really negative 24. So if I write this in the order that the complex numbers typically go, my answer would be negative 24 minus 12i. And I won't be picky as to which order you write them, because when I'm adding and subtracting, the order does not matter when I write these, because addition is commutative. Remember that. So that's my answer, negative 24 minus 12i. Let's do another one. Let's do one more. Maybe two more. So 7 plus 3i times negative 4 minus 9i. So 7 times negative 4 7 times negative 9i, 3i times negative 4, 3i times negative 9i. Everything in the first parentheses has to be multiplied by everything in the second parentheses. 7 times negative 4 is negative 28. 7 times negative 9i is negative 63i. 3i times negative 4 is negative 12i. 3i times negative 9i is negative 27, and then I times I is I squared. Okay, well, I can combine these middle two together. Negative 28, negative 63 minus 12 is negative 75i. And then negative 27i squared is really negative 27 times negative 1. Well, negative 27 times negative 1 is really positive 27. And now I can combine together negative 28 and positive 27. Negative 28 plus 27 is a negative 1. And then my minus 75i. Negative 1 minus 75i. That would be my final answer there. Negative 1 minus 75i. Okay. So you might be wondering, Mr. Burrell, how random? Why do we talk about complex numbers? Where in the real world would people use complex numbers? Well, some of the areas where people use complex numbers, some of the applications that it has in like the professional field, electrical engineers is one of the biggest examples. Electrical engineers have to deal with complex operations in the complex number spectrum a lot. In like cellular and wireless technologies, they use complex numbers with radar, quantum physics, if you're into that, etc. There's other operations, and we'll also continue to talk about complex numbers in Math 2 and in Math 3, so that'll be helpful going forward. That's some of the areas where complex numbers are used in the real world. So this was kind of a short one, but I hope at the end of this lesson that you understand this critical point, that I squared is equal to negative 1 and I is equal to the square root of negative 1. Hopefully you can multiply complex numbers together and understand that multiplying complex numbers is pretty similar to how you multiply polynomials with this addition, recognizing that I squared is equal to negative 1. So I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. Let me know. And I hope that you enjoyed that as much as I did.